Hi everyone watching right now. The question on board is about bearing and distances, all right? I am here to make it easy for you and understandable so that any question from bearing and distances, you can solve it very easily, all right? The question on board says a car traveling at 10 kilometers south, then 8 kilometers east. Find the car's bearing from its starting point to the nearest degrees. Okay. Now the first thing to be done on this question is to sketch it. Okay. We are meant to understand that the car first traveled to the north at a distance of 10 kilometers. Now let us sketch. First of all is to find our four cardinal points: north, east, west, and south. So this car now started at this point. This is the point it started. The north side is this place. The southern side is here. The west and east sides are represented. Now, this car now that started here move to the south up to 10 kilometers. Move down to the south up to 10 kilometers. Okay? Now 10 kilometers and stop here. All right. When it stops here, we still have our four cardinal points. Okay. Here is the east, west, north, and south. Now, after it has traveled 10 kilometers, it now travels. The question says that then moves 8 kilometers to east. We now move 8 kilometers to east. This side is our east side. Okay. Now, and stop. So, in order for you to solve this question, every bearing and distances ends up with a triangle. Okay. We now complete our triangle. If it stops here, we still have our four cardinal points. If you still stop here, now we now complete our triangle in order for us to solve it. Okay. Now complete it. So this line now represents the bearing of this car had it been started here to move. Now the question now asks us to find the car's bearing from its starting point. This is the starting point. So the car's bearing will be from north to east and move again to this line that connected the car where it is right now. Okay. Now the question is asking us the angle from here to here. And we know that from here to here is 90 degrees. Okay. And from here to here is also 90 degrees. So if you can get angle here with the help of this triangle, it is already solved. Now, we remember that this triangle here is right angle triangle by here because here is 90 degrees. Now, let us first of all and find this angle to enable us get the bearing. Okay. Now, remembering our SOHCAHTOA, remembering our trigonometric ratio, we can understand that this is the angle that we want to find. Okay. Now, and we already have here to the 8 kilometers when the car moved. Okay. Now, since we have this angle and the opposite to this angle is this line 8 kilometers, and adjacent to this angle is here 10 kilometers. Now, what type of trigonometric ratio we will use concerning the information we have? It is tan. Tan says tan this theta we are looking for equals to opposite, okay, which is 8 all over adjacent, which is 10. All right. Now, in order to find this angle now, this angle theta, we will find the tan inverse of this 8 over 10. Therefore, the angle theta is equals to tan inverse, that is tan raised to power 1, means tan inverse of 8 over 10, which will now give us 39 approximately. Remember they say we should we should get this to the nearest point. So we now get approximately 39 degrees. Okay. Now finding the bearing. Now since this place is 39 degrees inside here, that means from here to here is 90 degrees, and when we subtract 39 from 90 degrees, what will remain? It will remain 51. It will remain what? 51. So it is now 51 we are going to add here. Therefore, the question, the bearing of the bearing of the car from the starting point will now be equals to 90 plus 51. Remember that from here to here is 90, then 50. When you from here to here 90 also, when you subtract 39, it will remain 59. It will remain 51. We'll now add it to 90. It will now give us 141 degrees. So that is the answer and how to solve it. Thank you so much for watching, and God bless. Take care of yourself. Please don't forget to subscribe, share, like, and comment on video. Remember also to follow. It depends on where you are watching from. Thank you so much, and God bless.